Today. So a transformation is a movement of the graph. So it's any movement of the graph. There's actually 3 types of transformations that you will learn next year in geometry, and those are translations, which are like slides. You probably learned them as slides in elementary school. And that just is like if you take like the book and slide it up, right? That's a slide. There's rotations. And that just means how many degrees it's turning. We won't be doing that, don't worry. And there's reflections, which is just like a flip. Okay, there? So, yes, you did learn some of those words. Probably not maybe you learned the correct vocab, I'm not sure. But the one that we're going to be looking at, there are some reflections, and there's some translations, but those are the ones that we're mostly going to look at. All right? So, let's talk about transformations. Okay, make sure your equation is always in slope-intercept form before deciding the transformation. We will compare to the parent function, which is f of x equals x. F of x is the same thing as y, so that just means y equals x. You guys hate this function for whatever reason. There's a 1 in front of the x and you're adding 0. So if you look at this graph over here, that just means you're starting at 0 and you go up 1 over 1. So that's all this graph is doing. It starts at 0 and it goes up 1 over 1, up 1 over 1. That's all the parent function is. It's just that oblique line, which means slanted line going through the origin, that goes up 1 over 1. We will compare to the parent function most of the time. Remember, in slope-intercept form, f of x equals mx plus b. M is your slope, which is a rise over a run. And b is your y-intercept. So we're going to be using these vocabulary words here. So if the slope of the parent graph has changed, then it can either be stretched or compressed. So think about stretching. If you were to stretch, right, you get taller, right? So stretching makes it a steeper slope. So stretching would mean a steeper slope. If the slope, and you're talking about absolute values, so these are absolute value bars, so if m, which is your slope, is greater than 1, then it is stretched from the parent, okay? So if your slope is bigger than 1, it is stretched, which means it's steeper. So the line will look steeper than the parent function. Okay, for those of you that know computers, and you know how sometimes folders come zipped. Yep. You've heard that before? Yeah. Those are compressed files, meaning they've made the file smaller, making it easier to send. So compression also puts pressure. So some of you guys use like compression sleeves and stuff for like sports. That pulls things tighter together, so it pushes it down, right? So compression is like making it less steep, okay? So it's less steep. Michael, I'll answer your question in a second here. Let me just finish this thought, okay? So less steep means that your absolute value of your number, m, so of your slope, is between 0 and 1. So this means slope is between 0 and 1. And that's absolute value. Mike, what's your question? Not in the middle of notes. You can wait until lunch. There's a lot of stuff in this lesson. And this is all in comparisons to the parent graph, y equals x or f of x equals x, however you want to say that. The absolute value of it. So we're always looking at slope as if it's positive.
So it's like 0.5 or something like that?
What?
So it's like 0.5 and point whatever, like 0 point something. It's like between 0 and 10.
Yeah, so it's like a decimal less than 1. Guys, if your slope is negative, it is reflected. So if your slope is negative, it is reflected. So if slope is negative, it is reflective. If your y-intercept has changed, meaning it's no longer 0, the graph of the new function will shift away from 0, 0 on the y-axis. So it'll either translate up or translate down. Translate means shifting up and down. So translate up if positive, and it will translate down if negative, which just means moves up or down. All right, so let's look at some of those parent graph ones first when you're ready. If you have questions, please let me know. All right. So we're going to graph f of x equals x and g of x equals 2x. So a lot of you guys complained about function notation. This is where function notation comes in handy because we're not just using y equals both of them. They both have their own name, which is really nice. So f of x equals x means that you start at 0 and your slope is 1. Because there's nothing at it at the end. So you start at 0, 0, your y-intercept is 0, and your slope is up 1 over 1. You guys still have your rulers, right?
That'd be correct.
And then you'll connect your points, and we're going to practice labeling them because we're going to have more than one graph on here. Good practice for your EOC. Speaking of EOC, don't forget to do your Clever assignment. I entered a bunch of Clever assignments in last night. So if you still see something missing and you think you turned it in, let me know, okay? So I tried to go back and check for that stuff. All right, so that one is f of x, which is also known as the parent. So this is the parent function here. It's the most stripped down version of a line. G of x equals 2x means you start at 0, there's nothing added at the end, and your slope is 2 over 1. So up 2 over 1, up 2 over 1. Make sure you guys are paying attention, please. And then we're going to label that as g of x. All right, so see if you have any questions for me about how I graphed it before we answer the next question there.
I still have a ton of questions.
You're not even on the right graph. No, we're on the first slide, and you're on the second one.
That probably explains it.
Is that why you're confused why I went up 2 over 1?
Yeah.
Or is that why you were confused or no?
Yeah.
Do you see that now? Okay. If it isn't, let me know if there's another question you have, okay? All right. Please, guys. I shouldn't have to say it every single time, all right? I know you're cold. I know there's things going on, but I would like to get through notes today, all right? So explain how the graph has been transformed in terms of the parent function. So how has the graph transformed from the parent function? So the two things you're going to look at are the slope and the y-intercept. And every single time when you compare to the parent. So how has the slope changed from the parent? So the parent is this one here, f of x, and this is the other function. How is that transformed? Yes? So what's the word we use for steeper? It got stretched, right? And it's stretched by a factor of the slope. So it's stretched by a factor of 2. Did it reflect at all? Did it become negative? Nope. So it's stretched by factor of 2. So it's steeper, and the factor is by 2, right? We multiplied everything by 2, essentially, is what that's saying. Has the y-intercept changed? No. No change. Okay. Questions there on that first example? Riley, are you fine now?
Yeah.
Okay. All right, next one. So we're going to graph the parent and its transformation. So remember, the parent is like plus 0 and 1. So our slope is 1 over 1, and we start at 0. So we start at 0 and we go up 1 over 1. Don't forget to label your lines since there's more than one line on there. There should be 2 lines on everybody's graphs, guys. So make sure you're graphing what I'm graphing. Both the parent and the other one. It's easier to compare them when they're graphed on the same one.
Yeah.
And then I graph the other one, which is also at plus 0 and has a slope of 1 over 2. So I go up 1 over 2, up 1 over 2. And again, label your lines. So I should have f of x and g of x on my graph. So that's what you guys should be doing right now. If you are already done, that's fine. So you talk about 2 things, the slope and the y-intercept when you're comparing it to the parent. So make sure you write those down so you know what you're talking about there. You're going to talk about the slope and the y-intercept, and you'll do the same thing on your graph. Okay, how has my slope changed? How has my slope changed? Remember, f of x is the parent, and this is my new one. It's compressed. It's less steep, right? And what is the factor it's compressed by? The slope is a half, so it's compressed by a half. Is it reflected at all?
No.
No. So it's less steep, which means compressed, and it's by the factor of the slope. How has the y-intercept changed? It didn't change. How many times do you guys ask every week? It's like each one of you, each individual will ask at some point in the hour.
What if you come back from lunch and you're like, I'm lunch?
That would be an issue if that happened.
Short-term memory loss. What if someone just stayed home and lunch, like the bell rang, they just I'm doing that today.
I'm not trying to
Oh, you gotta get to the table today. I'm standing here doing lunch.
Okay, so wait.
You're not staying in here during lunch because I'm not in here. Yeah.
I'm just
How
gonna
do
stay.
you know it's like plus 0?
Huh?
How do you know it's plus 0?
If there's nothing added to the end.
So if it's just
If there's nothing added to the end, like a plus number, then it's plus 0.
so if it's just like x is just plus 0, but if
Or if it's equal to 2x. Yes. All right, guys, focus. I think we're all caught up now. Focus. I was just waiting for people to get caught up. Do you understand what I'm saying, Emma?
Yeah.
Okay. So we're going to graph the parent. So since there's nothing added to the end, it's plus 0. And we have a slope of 1. It's the same parent we've been graphing, so that starts at 0 and goes up 1 over 1.
Good start up.
So this one we start at 3, and our slope is a 1, so we go up 1 over 1. Somebody said something. What kind of lines are these?
Parallel.
They are parallel. Not that we're going to really talk about that much yet, but we will in the next part of this unit, because this unit is split into 2 parts. Remember, your test is next week, but in the next part of the unit, we will be talking about equations of parallel lines. What do you guys notice about the slopes of these 2 lines? They're the same. That's what you. So when we get to writing equations of parallel lines, they have to have the same slope, is what we're going to be looking at. But again, that's not until the second part of this unit. Okay. So we look at the slope and the y-intercept. Is there any change in our slope? No. If it were negative, it would have been reflected. Is it reflected at all? No. Does it change at all, though? No, they're both 1, right? We said if it's bigger than 1, it's stretched, right? The absolute value of it. If the absolute value is between 0 and 1, then it's compressed. But it is still 1. If it's still 1, then it hasn't changed. So the slope is now changed. How has the y-intercept changed, guys? We don't use stretch and compress for that. Up 3, right? So we use the word translate, because that's what you guys will get used to in geometry. It goes up 3. So if you say translates up 3. I'm using this vocabulary because the EOC last year had random vocabulary, and they don't tell us what vocab is going to be on the EOC. That would be a little bit helpful so that we can teach you with the right words. All right. Questions on comparing to the parent before we talk about other transformations? Questions about comparing to the parent before we talk about other types of transformations? So what are the 2 things you look at when you're comparing to the parent?
Slope and y-intercept.
So the y-intercept's pretty easy. It's either going to go up or down. So it'll translate up if it's positive, translate down if it's negative. The slope, you're looking for it to be stretched or compressed. Absolute value bigger than 1 is stretched. Absolute value between 0 and 1, compressed. Still 1, then it's the same. If it's negative, it's reflected. Okay? Questions on that? Okay. Here's how we're going to compare 2 functions that may or may not both be the parent. So if one is not the parent, and it just asks you to explain how one was transformed from the other, we will use these. Sorry. Okay, please listen. F of x plus or minus k translates or shifts the graph of f of x vertically. So if you add k, it translates up. If you subtract k, it translates down, meaning it shifts down. And it will shift up or down whatever k is. So k will become a number. Okay, this is really confusing. So please pay attention. For the translation on the inside, so if it's on the outside of the parentheses, it's a vertical shift. So if it's outside the parentheses, it's a vertical shift. If it's inside the parentheses, it's a horizontal shift. So know that. So if it's outside the parentheses, it's a vertical shift. If it's inside the parentheses, it's a horizontal shift. So vertical is up and down, horizontal is left and right. They use HK for vertexes and stuff too later on for standard form. So I'm wondering if it's just like the letters they decided to use at some point, because they can't use X and Y because X and Y are already in the equation. So I'm wondering if they're just 2 different variables. Somebody else decided. But technically, I mean, H instead of like HV, you're saying, probably because H and K are closer together. I don't know. A, B, C, D, E, F, G, H, I, J, K. I don't know. Somebody just decided those were the variables, I'm assuming. Yeah.
There's like an exclamation mark on my calculator. What is that?
That's a factorial. We won't be using that this year. All right. So listen to me, because this is going to get really confusing. If you add h, you're not going to go to the right. You're going to go to the... Yes.
Excuse me. What?
Subtract h means you're going to go to the right. How many of you have had math lab yet? Did you guys talk about this stuff? Did you talk about it being the opposite for that or no?
No.
You just retook the quiz. You didn't do this part? You didn't do these things yet? Okay.
Wait, what's math?
Okay, and f of x equals negative x means it's a reflection across the y-axis. All right.
This is too much.
I know.
My brain is
All right. When you're ready, flip to the examples. We're going to start doing some examples here. And then you get to come back and continue notes.
Just do one example and take a nap.
No. All right. So let f of x equal 2x minus 1. Find g of x equals f of x plus 3. So first of all, g of x is your new function. What it's telling you to do is add 3 to the f of x function. Look back on the previous page. If it's outside the parentheses, is that a vertical or a horizontal shift? This is a vertical shift. It's outside the parentheses. Okay, so what is the transformation then? What does adding 3 mean it's going to do if it's a vertical shift?
Up.
It will go up 3. So g of x shifts or translates up 3.
Yes.
From f of x. Does the slope change?
No.
No, we're not going to be doing anything that changes slopes. That's a dilation, and we're not going to be talking about that. So if you see the word dilation on your EOC, it's a change in the slope, essentially. Okay?
You got it.
Dilation, have you guys ever been to the eye doctor and they dilate your eyes?
Yes.
So that just changes like the size of your eye, to your pupil. So,
I did it.
f of x, we're going to graph f of x first, and then we're going to shift it. So I'm going to start at negative 1 and go up 2, right 1, up 2, right 1.
What?
I'm graphing f of x.
Up.
If you're still confused, please let me know.
A little confused.
Okay. So f of x is 2x minus 1.
Oh, no, never mind.
So I started at 1 and went up 2 over 1. You good now?
Yeah, I'm good. I was just a little...
Guys, if you're ever confused, just let me know. It's okay. It doesn't bother me. So, f of x is that one there. So go ahead and write that down. We know it's going to translate it up how many?
3.
Up 3. So it's going to take every point on the graph and shift it up 3. So if this one's at negative 1, it's going to go up 3. So it'll go up 1, 2, 3, and be at 2. If this one's at 1 and it shifts up 3, it'll be up at 1, 2, 3. So it'll be at 4.
Whoa, that's spicy.
And if this one is at 3 and it moves up 3, it's at 6. And then you can connect your point. And that's your graph of g of x.
I don't like it. I miss addition.
I miss 2 plus 2.
Way back in kindergarten, probably now. Everything has shifted down.
No, last year.
Yeah, what happens?
Let's be honest. It's crazy how things have
Like
shifted.
the stuff we learned.
All right.
we're actually gonna use.
So what is the equation of g of x then? What is the equation of g of x then? Who can tell me?
Oh man. Wait, is it? Wait.
2x plus what?
No, Justin.
It's not plus 3.
Minus. No. 3.
Plus what? Where's it starting at? 2. Okay, here's how you can do that algebraically. Listen to me. Here's how you can do that algebraically. We know g of x is equal to f of x plus 3. Do you guys agree with that? Is that what it says? F of x is the same as 2x minus 1. minus 1 plus 3 is 2. Is that what we got here?
Yeah.
So this is from the graph. We pulled the y-intercept from the graph. We pulled the slope from the graph, up 2 over 1. Or you can figure it out algebraically. So giving you that or situation, okay? Questions there? Are you on the right round? You're writing it on the wrong one. Pay attention, guys.
We have dose
I know. Well, we're fine. I'm aware.
but I need to eat.
All right. Okay, f of x equals negative 1/3 x plus 5. G of x is f of x minus 2. So it's outside the parentheses. So is this a vertical or horizontal shift?
Vertical. Horizontal.
No, it's vertical. So how will it translate the graph? It's subtracting, so it is.
Down.
It's not a horizontal shift. So yeah, so g of x shifts down to, or no, I shouldn't say shift, sorry, translates down to from f of x. I know. So I'm going to start graphing f of x. F of x starts with a y-intercept of 5. And the slope is negative 1 over 3, so that means down 1, right 3. It needs to make a negative slope. So if you go up 1, you'd go left 3. Okay, head to lunch. And when you guys get back, we'll finish this. To lunch, and we talked about the subtracting. It's on the outside of the parentheses, so it's a vertical shift. You read vertical shifts as is, so it translates down to from f of x. So then we were in the process of graphing f of x, so I started at the y-intercept of 5, and the slope is down 1 over 3. So you guys should be graphing that now. I think that's where you guys were at. So make sure you graph that on your graph now. So you should be graphing f of x equals negative 1/3 plus 5, and make sure you label it. It's really important you're labeling your graphs. I've been doing it on all mine. Have you been doing yours? You have 2 lines on there. Get used to labeling them. On the EOC, if you have to graph on the performance event day, you're going to need to label them. And then g of x is just taking f of x and shifting all points down 2. So if you're at 5 and you shift down 2, you're now at 3. If you're at 4 and you shift down 2, you're at
2.
You're at 2. And if you're at 3 and you shift down 2, you're at
1.
So you just shift all the points down 2. So get both of those graphs. They should look parallel. Some of you guys.
I don't know what I did.
It's this point that needs to shift down to. So it'd be right here. All right, guys. No turning around. Come on. Focus. Guys. Focus. Please. All right. So then it says state the equation of g of x. We can get the g of x equation from the graph. It starts at 1, 2, 3 on the y-intercept. So that's 3. And the slope is down 1, so that's negative 1. Right 3, so that's positive 3. So that's negative 1 over 3x. So you can do it that way. That's from the graph. Or you can plug it into the fact that g of x equals f of x minus 2. You guys need to stop talking. And we know that f of x is negative 1/3 x plus 5. And then we subtract 2 from that. So we still get the same thing there. So notice, algebraically and from the graph. See if you have questions there. Yes, Gina? What 5? The one here?
Yeah.
F of x is negative 1/3 x plus 5. So I just replaced f of x with that. And then I took 2 away from it. Okay, does that make sense?
Yeah.
Other questions? Right, horizontal shifts are next. This is confusing. You have to remember which one is opposite and which one is not. So notice it's inside the parentheses. It's inside the parentheses. You guys see that?
Yeah.
So it's a horizontal shift, and it's opposite. Horizontal shifts are always opposite. So instead of you thinking that it's left 3, this is actually right 3. So state the transformation. G of x translates right 3. So we graph the original. The slope is just 1. Do you guys see that? So it's up 1 over 1. So we are looking at the horizontal, which is the x-intercept. So the x-intercept is changing. So we're going to be looking at this to change, okay? And we said we're shifting the graph right 3, correct? So every point goes right 3. So if it's at 0, it shifts right 3 to 3. If it's at 1, it shifts right 3 to 4. And if it's at 3 and it shifts right 3, it goes to 6, and so on and so forth. So you're just shifting every single point 3 from the original. Oh, I forgot to label that. So this one is f of x, the original. You are going to need to use your notes tonight. You are going to need to use your notes tonight. Use them. Some of you guys throw them in your backpack never to see them again. I think that's most people, actually. Use your notes. Get used to using them. In college, like for me, teachers would teach lessons. I wouldn't even know what the heck was going on, so I'd have to go back and look at my notes again to reteach myself things, okay? Not that I want you guys to have to do that, but my point is use your notes, okay? So we graph both of them. What is the equation of g of x from the graph? Well, it starts at 1, and it goes up 1 over 1, so you're at just x. So that's how you would do that from the graph. How about algebraically? What do you guys notice about this? This is inside of it, right? So remember when it's inside, it's an input. Do you guys remember me saying that? So we said that g of x equals f of x minus 3. Do you remember that whole input-output process? So this means that this is the input, which means x equals x minus 3. Confusing, isn't it? So we know that g of x is taking f of x and plugging in. So f of x is x plus 4, right? Is plugging in for x minus 3 plus 4. So I replaced the x in f of x. So do you see how f of x is x plus 4? Do you guys all see that? I replaced it with x minus 3. So if you do minus 3 plus 4, that's x plus 1. Is that the equation we wrote from the graph? Yeah. So do you guys see how we're looking at the intercept? So we're not looking at the y-intercept for this one. We're looking at the x-intercept for this one. So even though the y-intercept did change, I do see that. We're looking specifically at the horizontal shift because it's a horizontal shift we're looking at here. So do you see how it moved from -4 to -1, which is right 3? Okay, if this confuses you, do you guys all know how to write the equation from a graph? Can you all write the equation from the graph? Okay, do you have to know how to do it algebraically? Do you understand when I says translate the graph right 3, how to take the points from the original graph and shift it right 3? Anybody confused there? And then you can just write the equation from the graph. So again, this is a little bit more advanced. So if this does not make sense to you, and you can do the other way, 100% okay. Does that make sense? I'm showing that to you guys so you guys know where all this is coming from. All right? Make sense? Please ask questions. I know this is not easy, okay? So please ask questions if you have any. All right. Some of you guys are in La La Land. Make sure you're writing notes, please. So g of x equals f of x plus 4. It's inside the parentheses, so is that a horizontal or a vertical shift?
Horizontal.
And is horizontal the same or opposite?
Opposite.
So we have to think opposite. So somebody please tell me what the translation is for this one. Lexi?
Down 4.
Be careful, it's horizontal.
Left 4.
Left 4, right? Horizontal is left to right. Vertical is up and down. So opposite of positive 4 is a negative 4, which means you're going left 4. So g of x translates left 4 from f of x. So it's just a shift. Remember, translate is just a shift, left or right, okay? In this case, since it's horizontal, it's left to right. So go ahead and graph f of x equals negative x minus 2. So go ahead and graph f of x equals negative x minus 2. So we start at, where do we start? And my slope is? Negative 1. Good. So we start at negative 2 and we do down 1, right 1. It should be a negative slope, guys. So you should be shifting all of your points left 4. So start shifting those points left 4. Start at one of the points and count 4 to the left for each of your points. So start shifting them. After you're done graphing that line, shift the points left 4. You can do at least 3 and then you're fine. Is that the same graph I have? Yeah, just making sure. You have the 2 lines already, so I was just making sure. So again, you're just shifting the points left 4. If anybody is confused about what I just said there, please raise your hand. If anybody's confused by what I just did there, please raise your hand so I can help you. Let me know. Who can tell me the equation of our new line g of x from the graph? From the graph, who can tell me the equation of that line? Where is it starting at? Where does g of x start at? It starts at negative 6. So we have minus 6 at the end. And what is our slope? Down 1 over 1. So down is negative, right is 1. Negative 1 over 1 is negative 1. So that's just negative x. Okay, algebraically, g of x equals x plus 4. It's inside, f of x plus 4. So this is inside, so it's an input, which means that x equals x plus 4. So I take the f of x function, and there's a negative x. So I replace x with?
He's gone now. He's gone now.
Oh, well, okay. X plus 4. And then I have minus 2. So all I did here in this function here is the f of x function has negative x. Do you see that?
Yeah.
I erased the negative x, and in its place I put x plus 4, but I kept the negative out front. So I distribute that negative through, and I get negative x minus 6. Is that what we got over there? Okay, so if you look at the horizontal shift, you can see that the x-intercept went from negative 2 to negative 6. So that is left 4. Do you guys see that? All right. A few more examples and then we will be done. All right. That's not funny. Stop. So, what does it mean when the x value is negative? Go back to that wasn't the very first slide, but it was one of the first slides before we started these. Somebody tell me what it meant. Yeah. Over which axis? What does it say?
Y.
Is that what it says in your notes, guys? Did you guys all look back? Do you know where you're supposed to be looking for this? It's not the first page. It's like one of the pages after those first ones. Does it say f of negative x is a? It's at the bottom of that page right in your hand, Miguel. What does that say? Do you guys all see that? Use your notes. They're good for you. So this is a reflection across the y-axis. So this just means that the graph is going to be reflected. So g of x is reflected over the y-axis. The reason that is because you're multiplying the slope by -1. So it goes from a positive slope to a negative slope. So that's why that happens the way it is. So we're going to graph 2x minus 1. So we start at -1. And we go up 2 over 1, up 2 over 1. So it's a reflection over the y-axis. So get that plotted, and then we're going to talk about how to look at this, okay? It's a reflection over the y-axis. So go ahead and get that plotted. We're going to start at the point 0, -1. If we reflect 0, -1 over the y-axis, where is it going to be? No, because it's reflecting over this. So think about it this way. You're folding the piece of paper on the y-axis. If you fold a piece of paper on the y-axis, is that point going to move? No, so that's going to stay where it's at. Where will this point go? Where will 1, 1 move to? Right, because it's 1 away from the y-axis here, so it needs to be 1 away from the y-axis over here. So where will 2, 3 go? Right, it's 2 away from the y-axis, so it needs to go 2 away from the y-axis on the other side. So that's how that works. Questions on that? Because that's a little different than what we've been doing. Do you have a question, Riley?
Yeah, how would we label it?
I forgot to label them. F of x is the original and g of x is the new one. So do you see how f of x is the original equation, and then it says the new equation is g of x in that statement?
I'm just confused because it said that it's not a negative.
Yeah, that's the equals part tells you what the transformation is. So if it's f of x plus k, that means it's moving up or down. If it's f of x in parentheses x minus k, h I mean, that is left to right, and then f of negative x means a reflection. All right, what is the equation of this? What is the equation of this one here? Jordan, what is the equation of this one here? Where does it start? Where, and what is its slope? 2 over 1, so be careful, you're close. Down 2 is negative, right 1 is positive, so it'd be -2. And then again, we know g of x is equal to f of x, or f of negative x, which is an input. So that means we are replacing x with negative x. Okay? So in the g of x function, or in the original function, we have an x here. So where we see x, we're replacing it with negative x. So that would be -2x minus 1. Is that the same thing we got here? Okay. One more slide and then your homework. I'm sorry, guys. A long day. The graph below shows the function f of x equals 6 over 5x plus 1. Explain the transformation from the parent. So how does this differ from the parent? Remember, we talk about its slope and its y-intercept. So how is its slope different from the parent? How is the slope of this different from the parent? Would it be helpful to graph the parent maybe? What's the equation for the parent? Who remembers the equation for the parent? Mike? Y equals x or f of x equals x, both the same thing. So I'm going to graph the parent on here. So the y-intercept is the easy part. How does the y-intercept change? How does the y-intercept change? How does the y-intercept change, guys, from the parent to the line here? Up 1, right? So it translates up 1. How is its slope changed? Is it stretched or is it compressed? Is 6 over 5 more than 1 or between 0 and 1? Yeah.
It's stretched.
Because 6 over 5 is a little bit more than 1. Just a little bit, right? So it's stretched by a factor of 6 over 5. So it's steeper, which means it's stretched by a factor of 6 over 5. Is it reflected at all? No. So when you're comparing to the parent, you look at its slope and its y-intercept. Okay, so the next one says the graph below shows the function negative 1/3 x plus 3. Explain the transformation made if the function is changed to g of x equals negative 1/3 x minus 1, sorry. So I'm going to graph that real quick. Does its slope change at all? Does the slope change at all? Does the slope change? No, they're parallel. What's the change then? How much does it shift? How much does it shift from here? Down how many? 4, right? If you count from here to here, 1, 2, 3, 4. So g of x shifts down 4. Oh, sorry, not down. Translates, I mean. Shifts. Translates. Same word as shift. Down 4. Oh my gosh.